Hi, my name is George Carlson. I'm with the Maker Barn, which is Makerspace just near the Woodlands, Texas. And I'd like to show you a project we've been working on. This is a Makerspace access control system. It's a system that's designed to allow access to potentially dangerous equipment to only those people who are authorized to use it. Right now, there is no card in the system, and the machine cannot be run. If I put my card in there, I'll get a solid green light and I can use the equipment. And if I take this card, this particular card is not authorized on this machine. I'll get a red light here, and the red light indicates the machine cannot be used, and of course it can't. But anyway, it's an interesting piece of equipment. I'd like to show you a few more details here in just a minute.
Makerspace MACS system is an easy system to install. There's only three major components in the whole system. First one being the Wi-Fi router. This Wi-Fi router is the type you can buy at any computer store. Some Wi-Fi routers you can get with a USB on the back, which is good because then you can use it to power up the server. The server is a Raspberry Pi Model 2. We like it. It's small, it's inexpensive, and it's very reliable. Third part, of course, is the MACS units themselves. These you can have up to 128 or 128 stations, and they're each individually addressable. What's not shown on here is a computer, tablet, anything running a normal browser can be used to control and monitor the system.
Here are the components that make up the MACS system. Here we have a router, a Wi-Fi router, and a simple thing you can buy at any computer store. Now this particular router is nice. It has a USB on the back which allows me to power up the Raspberry Pi. Raspberry Pi is a server, and the MACS units here communicate to the server through Wi-Fi, and a browser can communicate to the server again through Wi-Fi. I'm just using my phone as a browser, and it's looking at the log. So if I put the device in a log, I think you'll see the log update, and then it changes. And of course, this could be I'd prefer to use a tablet or something with a larger screen, but we can store a lot of data. We can store who's using machines, when they're using the machines, how long they're using the machines, who and when changes are made to the system. All these things are logged, and we'll cover about that in the software a little bit later. But you can see it's a very simple system. Only requires one router, one server, and up to 128 MACS units, and really as many devices as you want to observe the data and control the system. Hi, I'd like to show you some more details and features of the Maker Barn MACS unit here. This has a acrylic cover, and then behind the cover is the main part of it here is actually machined from corian, which is a very strong and chemical resistant material. Badge slides in like this. It's held in place by gravity. If you bring some dirt or chips in, they'll fall out through the bottom. There's a slot cut all the way through, and if you get some dirt in the corners, just blast out a little bit of air. On the back side, you see a gasket. Now this unit isn't waterproof, but it certainly is splash proof. It's dust proof and chip proof, so whatever surface you mount it on is not going to be compromising the equipment or itself if you get a little water or oil on it. Good way of mounting this thing is this Neiman enclosure. This is a non-metallic single gang enclosure. These are available at home centers, hardware stores, electrical supply, that sort of thing. They're inexpensive, and they seal real well. The gasket, there's 4 places for screws. It'll screw down nice and tight. You can have a good, well-sealed system. It's very rugged. Another way of doing this is to surface mount it. This device right here is mounted again, on the front of an electrical enclosure, but it could be mounted on the front of your equipment. And it requires a rectangular cutout and 4 screw locations, and you're all set. It's a good, easy, rugged way of mounting it. Let's talk a little bit about the electrical side of this, electronics. This is our circuit board. This has a particle photon processor on it. Very powerful little processor. The processor has Wi-Fi built on it, and you can see there's a small Wi-Fi antenna right here. This is the internal antenna, and then we can also, if we place this jumper on here, we can use an external antenna. External antenna improves your range a little bit and perhaps reliability. Now these jumpers right here, they set up the station ID number. Each machine has a particular station ID number, and when we talk about the software interface later on, we'll talk about the machine ID numbers. But this is where you tell the unit what his ID number is. And these jumpers, they're labeled 1, 2, 4, 8, 16, 32, 64. So you just place a jumper wherever you need that number. That'll add up to the desired number that you want. For instance, if you wanted number 23, you'd put a jumper at 16, 4, 2, and 1. That adds up to 23. It's just that simple. You don't need to be a computer whiz to figure that out. There, on the electrical side, we have a relay right here. And the relay actuates whenever a card is detected that that's in its system. Now the relay is rated at 10 amps at 240 volts. So there's plenty of drive. The relay is available. Output are available here. The wiper and the normally open and normally closed are all available on this connector, and these can be used to directly drive a control loop in your machine, or a contactor, or whatever. There's quite a bit of power here. Now if you need to drive a solid state relay, then you can use this relay in conjunction with the 5 volts and ground available here to provide the bias for the relay. Or, if you would like, you can remove this relay. There are some lines that are silkscreen on the board, and you put jumpers in those locations, and then you can use these connectors here to directly drive the solid-state relay, which is kind of a nice thing to do. Now the power input, this thing is very low power. It's in idle mode. It only draws about 600 milliwatts. And when it's actuated, it only draws just a hair over a watt, so it's very low power. This is where the power is brought in this connector right here. And it can be 8 to 24 volts, either AC or DC, doesn't matter. And when you hook up DC source, it doesn't matter where you connect it. You can't hook it up in reverse. There's a little bridge rectifier here that, so polarity doesn't mean anything here. Now, a good AC source, well, DC source, you could use a DC that's somewhere in your equipment, or you can use a wall wart, something like that. Or if you want to, AC power sources, a small transformer, such as this triad transformer. This is a triad F216X. It outputs 12 volts AC, and it works quite well. Another way of doing it is just using a simple bell transformer. Bell transformers are available at hardware stores or home centers and that sort of place. You can even get bell transformers with 240 volt input. So it'll be good if you have 240 volt equipment. But anyway, that's pretty much it for the electrical side, and this is very easy to install and very reliable. This miter saw is a good example of how the MACS system could be used with a corded tool such as this miter saw. We have a box here, and inside this gray box is a solid state relay and a duplex outlet. The miter saw is plugged into the outlet, and also a vacuum cleaner as well. And they can't be unplugged because the cover is on the box. And the vacuum cleaner is nice. We have an automatic vacuuming system for the miter saw. So what happens when I plug my badge in, it will activate the vacuum cleaner and enable the saw to run. pull out the badge and the vacuum cleaner shuts down and I can go work on other projects.